Your EC2 server is running fine until the disk fills up. Do you tear the whole machine down and rebuild it larger, or do you simply attach more storage the way you would plug a second hard drive into a laptop? That is the puzzle this lesson solves. An Amazon EC2 instance is a virtual server in the cloud. It comes with a built in system disk called the root volume that holds the operating system. But the root volume is not unlimited storage. When you need more space for data, logs, or databases, you do not replace the server. You attach something separate. Think of the instance as a small workspace with one built in shelf for the operating system. When that shelf is full, you roll in an extra storage cabinet and bolt it to the side. The workspace stays put. The cabinet is the extra capacity. You should now be able to see why a server can need storage that is separate from the server itself. The rest of this video shows exactly how Amazon gives you that cabinet and how to attach it step by step. The cabinet has a name, Amazon Elastic Block Store, or EBS. EBS is persistent block level storage designed for use with Amazon EC2. In plain language, it behaves like a virtual hard drive attached to a virtual server. Three words matter here. Persistent means the data can outlive a single session of work on the instance. Block level means the volume looks to the operating system like a raw disk you can partition and format, not like a shared file folder in the cloud. And attached means the volume is connected to a specific EC2 instance, so that instance can read and write blocks on it. Here is the part that matters. EBS separates compute from storage. The EC2 instance is the brain and the CPU. The EBS volume is the durable disk. You can size them independently. You can choose different performance profiles for different jobs, and when you need more space, you add another volume instead of rebuilding the whole machine. A common misconception is that launching an EC2 instance somehow gives you infinite disk. It does not. The root volume is finite. Extra capacity comes from additional EBS volumes you deliberately attach. Not every storage cabinet is the same. Amazon EBS offers four main categories, and each one trades cost, speed, and how often you plan to touch the data. First, general purpose SSD. The types called GP3 and GP2. These balance price and performance. They are the everyday choice for boot volumes, web servers, and development or test environments. If you are not sure what you need, start here. Second, provisioned IOPS SSD, IO2 Block Express, and IO1. These are built for high-performance, IO-intensive work. Think relational databases or NoSQL systems that hammer the disk with many small reads and writes. You pay more because you are buying guaranteed IOPS. Third, throughput optimized HDD, type ST1. This is a low-cost hard disk option aimed at large sequential streams, big data processing, data warehousing, and log processing. You care about megabytes per second flowing through, not tiny random IOPS. Fourth, cold HDD, type SC1. This is the lowest cost option for data you touch infrequently. Archive-style workloads live here. Notice the pattern. Faster is not always better, and cheaper is not always worse. The right volume type is a workload choice. For the walkthrough in this lesson, we will pick GP3, general purpose, because that is exactly what the procedure uses for a simple additional volume. Now we move from the idea of a storage cabinet to the actual AWS console. Step 1 is simple. Open the EC2 dashboard. From the AWS Management Console, you go to All Services, then choose EC2 under Compute. That lands you on the Amazon Elastic Compute Cloud Home, the control panel for virtual servers in your account. On that screen, you will see navigation for instances, images, Elastic Block Store, and network security. The orange Launch Instance button is the doorway into creating a new virtual server. We are about to walk through that doorway, but pause for a second on why we start here. You cannot attach a new EBS volume in a vacuum for this tutorial's flow. The source procedure builds the host and the extra volume together at launch time. So the dashboard is both the map of your existing fleet and the starting line for a new instance named, in our case, EBS-volume. You should now be able to see where the operation begins, the EC2 service home, before any AMI or disk size is chosen. Step 2. Click Launch Instance. That single control opens the Launch Wizard, the multi-section form where you describe the virtual server and, critically, its storage. On the EC2 landing page, the Launch Instance button sits in the Launch a Virtual Server card. Clicking it does not instantly bill you for a machine. It opens a configuration canvas. Name, image, size, keys, firewall rules, and storage all get decided before anything actually starts. This is where the workspace metaphor becomes concrete. Until now, the cabinet was abstract. From here on, every field we fill is either describing the workspace itself, the compute, or describing the shelves we bolt onto it, the volumes. Keep your eye on the summary panel that appears on the right as you configure. It will eventually show how many volumes you are creating and their total size. That summary is how you double-check the extra cabinet before you commit. Step 3. Configure the instance itself. 5 decisions, one after another. First, give the instance a name, EBS-volume. Names are labels for humans. They do not change performance, but they make the console readable when you have many servers. Second, select the Amazon Machine Image, or AMI. Choose Amazon Linux. The AMI is the starting photograph of the disk, the operating system and base software baked into the root volume before you ever log in. Third, choose the instance type T2.micro. Instance type is pure compute, how much CPU and memory the workspace gets. T2.micro is a small, inexpensive size often used for learning and light workloads. Notice we are not changing storage yet, only the brain of the machine. Fourth, choose an existing key pair or create a new one. The key pair is how you prove who you are when you SSH into a Linux instance. Without it, you may not get a shell. Fifth, choose an existing security group or create a new one. A security group is a virtual firewall. It decides which ports and protocols can reach the instance. Web traffic, SSH, nothing at all, those rules live here. You should now be able to see which settings describe the server, name, AMI, type, keys, firewall, and which setting, coming next, will describe its extra storage. Step 4 is the heart of the lesson. Configure a new EBS volume. In the Configure Storage section, you will already see a root volume. In the console capture from the source, that root is 8 gigabytes, type GP3, the system shelf that holds Amazon Linux. Do not confuse resizing this root with adding capacity. We are going to add a second row. Click Add New Volume. A second line appears. Set the size to 10 gigabytes. Select GP3 as the volume type for general purpose usage. Leave the rest at sensible defaults for this walkthrough. The source keeps the focus on size and type. Watch what the summary panel does. It updates to show 2 volumes, totaling 18 gigabytes. That is your signal that the extra cabinet is planned alongside the original shelf, not instead of it. A frequent misconception. People think selecting 10 gigabytes means the root disk became 10 gigabytes. It did not. The root stays 8. The new volume is 10. Together they are 18, addition, not replacement. When the size and type look right, click Launch Instance. AWS provisions the virtual server and attaches both volumes as the instance comes up. Step 5, Verification. After the instance launches, open it and check storage. The source states the success criterion in 2 lines. Root volume, 8 gigabytes. Additional EBS volume, 10 gigabytes. Seeing both confirms the extra EBS volume was successfully attached to the EC2 instance. On the Instance Storage tab, you can go further. Root device details show the root device name, typically something like /dev/xvda, and that the root device type is EBS. Under Block Devices, you see a table of volumes. One row is the 8 gigabyte volume on the root device name, state in use, attachment status attached. The next row is the 10 gigabyte volume on a second device name, also in use and attached. Two volume IDs, two sizes, same attachment story, both bolted to this instance. You should now be able to verify attachment by seeing both the original root volume and the additional EBS volume side by side, not by hoping the launch button worked, but by reading the console evidence. Let's slow down and connect the pieces so the procedure is not just a click path. EC2 is compute, EBS is block storage. At launch, AWS can create the root volume from the AMI and create additional volumes from the storage section of the wizard. Each volume gets a volume ID, a size, a type such as GP3, and an attachment to a device name on the instance. Why attach at launch rather than later? You can attach volumes later too, but this tutorial's documented path is launch time attachment. The extra 10 gigabyte GP3 volume is declared before the instance exists, and it arrives already attached. That is efficient when you know the capacity you need up front. Why GP3? Because general purpose SSD matches boot disks, web servers, and dev or test work. Exactly the balanced tier from the type table. If this were a production database with fierce IOPS needs, the same wizard would let you pick provisioned IOPS instead. The mechanism is the same, only the cabinet grade changes. And why keep the root at 8 gigabytes while adding 10? Because the operating system does not need to grow for you to store application data elsewhere. Separating system disk from data disk is a classic operations habit. EBS makes that habit easy in the cloud. 2 volumes, 2 roles, 1 instance. Plain language restatement. Attachment means the block device is connected and visible to the instance. It does not by itself mean a file system is mounted or a folder is ready for files. The source stops at attachment, and so do we. Zoom out. Amazon Elastic Block Store gives EC2 persistent block level storage, virtual hard drives for virtual servers. Volume types map onto different jobs. General purpose SSD for balanced everyday work, provisioned IOPS for demanding databases, throughput optimized HDD for big sequential pipelines, and cold HDD for infrequently touched data. The procedure we followed opens the EC2 dashboard, launches an instance named EBS volume on Amazon Linux as a T2 micro, sets key pair and security group, adds a new 10 gigabit GP3 volume beside the root, launches, and verifies an 8 gigabyte root next to a 10 gigabyte additional volume. The broader idea in cloud architecture is the same metaphor we started with. Compute and storage are separate levers. You choose the workspace size and the cabinet grade independently, then bolt them together. One open question the same style of reasoning can attack next. What would you need to do inside the operating system, formatting, mounting, permissions, before an application could actually write files to that attached volume? The console showed attachment. Usability inside the guest is the natural sequel. You came in wondering whether to rebuild a server just to get more disk. You should leave knowing you attach EBS instead, and exactly which clicks make that real.